Welcome to this second lecture. We are going to discuss RSA encryption scheme. So we first discuss the cryptographic procedure or the need for the cryptographic techniques. For this, consider this standard example where Alice wants to send a confidential message to Bob. However, if an intruder is sitting on the communication channel and you can see everything which is communicated through this channel. To overcome this situation, Alice and Bob uses cryptographic procedure in which Alice encrypts her message M using a encryption algorithm E and generates a ciphertext or a private message. Now she sends this private message to Bob using the communication channel. Bob, on receiving the message, decrypt it using the decryption algorithm D and retrieve the message M. Intruder Eve can only see the ciphertext C on the communication channel. By ensuring that he cannot get message M from the ciphertext C, we can provide privacy to this communication channel. So coming to the RSA encryption scheme, RSA is an asymmetric key crypto system. That means that there are two different keys for encryption algorithm and for decryption algorithm. To get a private message, Bob has to publish a public key. Now, public key will be used by Alice to encrypt the message, generate the ciphertext, and send it to the Bob. Now Bob, on receiving the ciphertext, will use his private key, which is assumed to be known by him only, using which he will decrypt the encoded message C and will get the message M. Eve can only see the encrypted message C, and it is assumed that he cannot decode this without having this private key. Thus, the secrecy of the message is maintained. Now we'll discuss the encryption procedure. For this, the Bob's settings are such that he has to first generate his public key, which he'll be publishing, and a private key which he'll be keeping secret. For this, he will choose two prime numbers P and Q and will compute a number N, which is P times Q. Now he will compute phi n, and by applying the modular arithmetic, he will generate two numbers E and D, which are inverse under modulo phi n. So E and D should be a number such that E times D should give us a remainder 1 when we divide by phi n. Having computed these numbers, he will publish his public key as N and E and will keep his private key secret as N and D. So performing a computation here, let us take this example. Suppose if he chooses the prime number P and Q as 11 and 3 respectively, then n is going to be 33, phi n is going to be 20. Now he has to choose the number E and D. Under modulo 20, the number E and D should be inverse of each other. So let's take E as 3 and D as 7. Now this is one such pair. There are so many possibilities under phi n for the choice of E and D. Now E times D is 21, modulo 20 is 1. So this choice is a valid choice of E and D. Having done this, he'll publish the public key as 33, 3. He'll keep the secret private key as 33 and 7. So it is n, E and n, D. So there is an error here. It's n, D. Now Alice, who want to send a message M to a Bob, will find the Bob's public key, which is NE. Using this E and the message M, she will compute M power E mod N, which is C. Now C is a ciphertext. So she will be sending, in place of the actual message M, an encrypted message C. So for example, if you want to send a message M which is 14, then for a chosen public key 33, 3, as in the last slide, 14 to the power 3 M to the power E modulo 33 is 5. So the encrypted message what she'll be sending to the Bob will be C is equal to 5. Now Bob, on receiving encrypted message C, will use his private key and will compute C to the power D mod N, and he'll get the remainder R. And this remainder R will match with the message M. So for example, on getting a ciphertext C is equal to 5, with his private key ND, which is 33.7, he will compute 5 to the power 7 mod 33, and therefore he will get the remainder R 14. And you can see that R is same as the original message M. So he will retrieve the original message M. So what we have understood in this particular lecture is the computational procedure, that how the encryption and the decryption can be performed. However, the noticeable point is that this choice of E and D depends upon, or a difficulty to break this E and D by if depends upon how big this number is, and that depends upon the big number P and Q. So by choosing this P and Q sufficiently large, we can ensure that these possibilities of E and D are enough. Also, it should be noted that the published key contains N, from where figuring out this phi n 20 on which we are performing the computation is not direct. So in the next class we will try to analyze the privacy guarantee of this encryption technique, that why this works and the privacy it provides. Thank you.